Okay, so I'm Rob Jones. I'm the product manager in Software AG for streaming analytics. And thank you for inviting me today to spend a few minutes just showing you how we think our customers can best use streaming analytics on the thinedge.io platform and really get to use streaming analytics on with some, I think, pretty essential use cases for those devices. So I'm joined today with my colleague Matthew Johnson. He's from the R&D team, so he's going to be taking you through a live demonstration of how we can use stream analytics on thinedge.io. So I'm going to start off with a introduction for streaming analytics. Now, apologies if you know what streaming analytics is. I'm going to make this very, very brief. Streaming analytics is a dedicated technology for looking at large amounts of fast-moving data in real time and performing actions on that analysis very, very quickly, i.e. with low latency. So I think of there's two types of streaming analytics. One is when you're looking at discrete events. You're looking at individual things that have happened and you're looking for a pattern. So you're looking for a temperature exceeding a limit, and then you're looking for vibration exceeding a limit. Now, if those two things happen in a very short space of time, then you might want to raise an alert, an alarm. And then the other type of streaming analytics is to look at the data stream as a whole and to do something against all the data points on that stream. So looking at the temperature measurements as they're coming in, but then calculating aggregates like averages, means, standard deviations on that data stream. So streaming analytics, I think, covers both of these types of analysis, and I'm going to go through how we can do that using thinedge.io. Where can streaming analytics be deployed? Well, the answer is pretty much everywhere. So we in Software AG, we provide streaming analytics for use in the cloud, in a containerized environment. We use it for, we provide it for use on servers, and we also provide it for use on edge devices, whether they're the thicker, more powerful PC, industrial PC type edge devices, or something much lighter like the ARM-based devices. So lots to read on this slide, and I'm not expecting you to read it at all, but I wanted to give a flavor for the types of use cases we have for streaming analytics. And I think of there's two types of use cases. One is the streaming analytics we would do against the device as a whole. So you can see, looking down the column on the left, you can see the sort of use cases that I see all the time with our customers. So they're looking at the types of alarms that are being raised and seeing, is there a pattern in those alarms? Is it one alarm a day? Is it 10 alarms in 2 seconds? And you can do the analysis just on the types of alerts or alarms that are being raised. And I can't go through each of these in the short space of time I've got, but other very well known use cases would be around predicting maintenance. When is the best time to service my device if it needs servicing? And then anything to do with remote control or monitoring is, of course, something that many customers are doing. So they are the device-focused use cases. We also have data-focused use cases. So looking at the data specifically, rather than how the device is behaving. So looking at the data, again, these are just a bunch of examples that I see in our industry. So people want to do aggregates on the data. So instead of identifying all the data points, I think what's sometimes more important is to look at the trends. So to look at the averages over the past, say, 5 minutes, and looking for anomalies in the data. So learning what the data should look like, and then identifying anomalous data points. And then there's a bunch here. So condition monitoring is possibly the most used example for streaming analytics, and it's things that you may do today, where you're looking at a measurement, comparing it against a threshold or a limit, and then if it's exceeding those limits, then raising an alarm, an alert. That is one of the simplest and possibly the most common type of streaming analytics. But I'm providing these use cases just to try and make you think that there's a lot that streaming analytics can do for the data that's going through your device. So today we're going to show you one example, and this example is available from the it's available from the GitHub repository, and that we'll share with you later. And the idea for this example is to highlight how we can deal with a limited bandwidth scenario where batching and compression are techniques used to deal with that limited bandwidth. So sometimes, and it's very frequent to be fair, devices can generate more data than we sometimes want to deal with. Sensors can generate readings multiple times per second. And if you've got multiple sensors, that is a lot of data being generated every second. And do we want to process all that data? So sending all the data off device can be heavy on bandwidth. And if you're paying for that data transfer, it can also be very expensive. So what we're going to be doing here is looking at the raw data and seeing if we can identify the trends and the means and the values over time windows, and use streaming analytics to change the raw data points on the left of the graph here into the more meaningful and lower frequency data points on the right graph here, and that will allow us to save on bandwidth and hopefully save our costs too. So we are using streaming analytics for this, and we're going to calculate the average pressure, temperature and vibration coming off our the sensors on our device, and we're going to calculate those averages over a 5-second window. Then we're going to batch those, we're going to combine those into a single measurement structure, and then every 5 seconds we're going to send that out over MQTT to the cloud environment for monitoring and alerting purposes. So we're getting a lot of data in every second. We're going to combine that, average it, and then send it out every 5 seconds. So we're drastically reducing the amount of data that we're sending out. So Matthew will take us through that in a few seconds. For this demonstration, we're using the Apama streaming analytics platform, the engine that we call Apama. And you'll see from the demonstration that Apama includes its own domain-specific language. Now that DSL, called EPL, is very similar to Java and C++, but it's aimed entirely at making event-driven pattern matching and stream manipulation as easy to develop as possible. That is the reason we have a DSL, is to make the task at hand as easy to accomplish as possible for developers. Now, there's a number of advantages to using Apama and its own and EPL. Now, one of them is it allows you to separate, if you're developing a device, it allows you to separate the control process within the PLC from the streaming analytics logic. So that means that your streaming analytics will not be running interchangeably with the same code that you've got running controlling your device. And it allows a developer to focus purely on the streaming analytics at hand without thinking how do they combine that streaming analytics logic into the PLC logic as well. And Apama is aimed at giving you high throughput with a finite amount of resources, and it's therefore optimized for performance out of the box. So while you can do your own optimization, you can rest assured that Apama will provide that optimization out of the box ready to go. Apama has a relatively small footprint, which makes it perfect for thin edge devices. So it's not a Java-based application, and therefore doesn't suffer from the overheads of running a memory-hungry JVM. It can be used on Linux environments or Windows, but for thin edge, we would expect our customers to be using Linux, and it works on x86 and ARM v7 architectures. Now, this example we're showing is running within 30 meg of RAM. It's using less than 100 meg of storage space. And if you're tracking CPU usage, well, we're processing 10 events per second in our example approximately. and it's using less than 1% CPU on our Raspberry Pi to do that. But if you wanted to max out that Raspberry Pi, then consider approximately 30,000 events per second doing the limited bandwidth example that we have, which is a very large number of events per second, as you can imagine. Apama is proven, it's robust, it's not a new product, it's been matured over a number of years, it's maintained by Software AG, and it's available commercially, fully supported by Software AG, or you can use the free-to-use community edition. And that's what we're using for this demonstration here. And finally, if you want to find out more information about Apama, what you've seen in the demonstration, then there is an Apama community site in the top right-hand corner of this slide. You can see the web address, apamacommunity.com. You can go there for all the downloads and documentation. There's a bunch of resources available to you, including blog posts written by Apama developers themselves, as well as from customers. There's tutorials in video form. There's access to the GitHub repositories for samples and utilities. Know that there's a Stack Overflow Apama tag, and I would recommend using the tech community, which is also linked in the top of the slide, if you want to have a discussion with the Apama experts on helping you do what you want to do. So with that introduction, I'm going to hand over to my colleague Matthew to take us through the demonstration.
Thanks, Rob. Hello, everybody. Today, I'd like to walk you through the process of building, testing, and deploying a streaming analytics application for thinedge.io. I'm going to be using the Software AG designer, which we provide with the full Apama installation as the IDE. But we do also have support for using a variety of other common development environments as well. I'm also going to be using Software AG's Cumulosity IoT as the cloud that thinedge is connected to and show its software deployment features via the cloud. This slide shows the architecture I'm going to demonstrate today. I shall be using Designer to write an application, and I'm using the built-in Apama instance there to test this during development, connected to a test thinedge.io installation that I have. And then once it's done, I'm going to deploy that application via Cumulosity to a thinedge device, which is then going to run the application within the Apama on the device and then talk directly to Cumulosity. So let me switch to a screen share to start the demo. Right, so first, here is my tenant on Cumulosity. You can see I've already got a thinedge device set up and connected, but it's not currently producing any measurements. The sensor data is currently being published within thinedge.io, but it's not being sent to the cloud. So we're going to start here in the Software AG Designer. This is our development environment for writing streaming analytics applications. As Rob said, Apama has a domain-specific language called EPL, which is expressly designed for creating real-time, event-based streaming applications. And that's what I'm going to be demonstrating today. So I'm starting here with essentially a blank project. I've configured it to connect to the MQTT broker on my test thinedge instance. And this will allow me to test the code whilst developing it before deploying it to the edge for real. I've also configured a few event types, which we're going to use for the sensor events that are being sent from within the device being received by Apama, and also the combined measurement event that's going to be published out to the cloud. So back to the application. EPL applications start in the onload method here. So the first thing we want to do is we want to subscribe to the measurements that are coming from the sensors on the device. So here, this is going to read temperature events. Then we're just going to start by receiving all the events and just logging those out to the console so we can see that it's working. Or, potentially you could have a simple threshold where you're looking for events which are above some kind of warning threshold, and then produce a warning to the log. So let's test this out. So if I run the project here, then this is going to start up the correlator, which is our engine that runs Apama and runs the application. The console here shows us the log output from the correlator. As you can see, we're getting a lot of data that's being produced by the sensors, but just receiving that and logging it to the console is not very useful. So instead, let's try sending that data to the cloud. So if I replace this, then you can see here we're sending this out to a different channel, and this is the one that's going to be published up to my Cumulosity tenant. So let's run that one. So this, like I say, contains all the information coming out of the correlator. We're no longer getting a big spam of events, but in the status lines, if you look at the TX off to the right here, you can see that we are sending data fairly regularly. And if I switch over to my tenant and go to the measurements, let's just switch that down to current, you can see we're producing a lot of measurements here, which are coming from the device. However, this is a lot of data, as Rob said. Many devices have restricted bandwidth, and it's also very spiky. So we want to smooth it out, and we want to only publish it periodically. So first of all, let's create an average and populate that. So I'm going to replace my listener that just receives all the events here, and I'm going to replace it with one of our streaming constructs here. So this is using EPL's built-in streaming features to calculate a mean over a window. The result of that mean is then going to be published up to the cloud as we had before. So this is going to smooth out the data. So let's run that and see what that looks like. So if we come back over to the tenant, then we can see that the data is now being produced in a much smoother fashion. This is from our aggregate. However, we're still publishing this very, very quickly, and we're still only doing one of these measurements that we were looking for. So let's come back over to the code again. The final version I'm going to show you today is what you'll see in our examples repository, which you can go and look up on GitHub. So we're going to start with that by not just receiving the temperature measurements, we're also going to subscribe to the other two types of sensor data that we're looking for. Now we want to calculate averages for each of those. So instead, we're going to have three of these stream components. And instead of sending them out as soon as we've calculated the current, we're going to just store them for later in these variables. Finally, we want to periodically do a little bit of data sanitization to make sure that what we're sending up is good, and then publish those up to the cloud. This also shows off the way that you can, in EPL, combine declarative concepts such as the stream statements there, along with event-based primitives with the on listener, and then just general imperative code, which allows you to create a lot more sort of flexibly and more powerful applications as you can combine these together. And it allows you to write applications which are a lot more flexible and can respond to changing conditions. Right, let's run this version that we have here. So now if we look at the console, what you'll see is that there are periodically events being created, but a lot less frequently. So you can see we're sending these with our averages here. And then we can switch back to the tenant, and we can now see that we will be getting data. Let's switch that all to minute view. we can see that you're getting data on all three graphs, and it's this slow, much more slowly evolving and infrequent events being published. So that's all great, and now we've got the application where we want it, but what we don't want is to be running it on my developer instance. So let's stop that. Now we're going to deploy it through the Cumulosity cloud. An Apama project can just be deployed to a directory with a bunch of files in it, and so I've just put that in a zip file, which I'm going to use to deploy into the cloud. To do that, I need to switch over to the software repository and add a new piece of software which we can have deployed. So the values I'm going to put in here just have some in the version here, I need to specify what sort of project it is so that ThinEdge knows how to deploy it. There we go. And then I just need to drag and drop the zip file with all of my project in it here, and I can upload that. Now I've got the project uploaded, I can switch back to my device. And I can use the software tab here to deploy it out to the device. So if I click install software, again, you can see it's all offered here, the thing we've just uploaded. I can select that. And now when I click apply changes, you can see it runs this to deploy it to the device. And now it should be up and running on the device. Again, it stopped here, we're not running it locally, but if we switch back over to the measurements here, we can again see that we're getting updates here periodically, and this is from the application that's running on the Edge device itself. So I hope that has given you all a brief overview of the workflow of building a streaming analytics application with Apama and with Cumulosity. Thank you very much. I think we probably have a few minutes now for Rob and I to answer some questions that you may have about using streaming analytics and ThinEdge. So I'm going to hand back over to Phil to see if we have any questions.
Brilliant, excellent. So, well, thanks, Rob, and thanks, Matt. So, kind of, I know the discussion regarding having edge data processing is actually one of the topics that came up in the last meetup. So, it's good to go through that now. So, just looking through the questions, there's one here regarding let's say the comparative advantages of Apama compared to Node-RED, because I think in one of the early questions, Node-RED was one of the most heavily used kind of programming tools for the IoT people who've actually joined. So could you articulate I don't know why Apama rather than Node-RED, or maybe there's some situations that make one better than the other?
I can give a couple of thoughts on it. There's no doubt that Node-RED is a popular environment. So it certainly has its uses. But I would highlight that Apama provides a level of performance which Node-RED can't really compete with. The overheads are super low with Apama compared to implementing the Node-RED environment on on devices, and Apama has been used for performance use cases for a number of years. That has meant that it's optimized and it's extremely efficient. I do get that some customers, some developers like the no-code environment, and it's something that we are looking to introduce to the ThinEdge.io in the future, in the cloud, and the thick edge within Cumulosity. We have a drag and drop environment for building streaming analytics, but our initial offering for ThinEdge.io is definitely focused on the developers, where performance and the low overheads are the key constraint. But good question.
Yep. So one of your sort of comments there, Rob, was regarding sort of previous uses of Apama, obviously in high data transfer environments. So I think there's obviously some cases before regarding kind of the finance sector. So they look for patterns and trends using the tooling. So are some of those models and methods readily available to be used on more operational technology environments? I know you went through a number of use cases there for data processing and for let's say device management. So are some of those methodologies easily reusable?
I'd say the rather than yes, absolutely is the answer. But it's one of the benefits of having a domain-specific language. Apama's EPL is entirely geared around making pattern matching in an event-based environment as easy to use as possible. It requires far fewer lines of code than trying to write that in any other language, and the fewer lines of code make it quicker to write and much easier to maintain. So rather than saying you could embed a lot of existing third-party libraries, I would highlight at this point that the domain-specific language for Apama makes creating these streaming analytics applications, which are doing pattern matching or they're doing analysis over the whole stream, really straightforward, really simple for a developer. Yep.
No, great. And maybe I know there's time's coming on, but maybe kind of one last question. So I know so Apama is pretty self-contained, isn't it? So you sort of manage that unit in itself. So does that also provide some sort of differentiation against, let's say, other mechanisms to do analytics? So you sort of separate some of the data processing from other code.
I think you might be referring to a couple of points I was trying to make on one of the slides, which is that on many lightweight devices, we see developers trying to embed streaming analytics logic inside the C or C++ code that's running on that device. And whilst that might be good for straightforward use cases, it doesn't make it as easy to maintain as separating out that logic. And that's where Apama can come in. Apama's a separate component that runs in a very small footprint that allows you to put all the streaming analytics logic in one place. It allows you to maintain that separately from the PLC logic itself, and that gives you, many benefits when running on a small platform where performance and accuracy and uptime are very important.
Yep. Great. So I think that's kind of run out of time for the Q&A, but I know so Rob and Matt, you already referenced some of the tutorials and use cases are on the thinedge.io website and also the Apama community website. So thank you very much for that.